Hello, everybody. Oh, okay, cool. Anyone here that attended my talks back in 2013 or 2014? Sweet. So y'all tell everyone else, 2013, I talked about variables as a far future thing that we might get to use someday. You just saw the result of that. 2014, I talked about grid as a far future thing we might get to use someday. You just a little bit ago heard Jen talk about the result of that. Or not Jen, Rachel, sorry. Today, I'm going to talk about another far future thing that we're going to be able to use someday. But this will be a little more speculative than before. Today, I'm talking about Houdini, which Philip Walton talked a little bit about yesterday in the context of polyfilling. I'm going to go a little bit more into detail here about the specs that are currently being developed. And then at the end, I'll talk about the specs that are on the burner that I don't actually have drafts of yet, but I'll give you the ideas of what we're going to be doing with them. I'll open, though, with a quote from Guy Steele. He's one of the forefathers of a lot of computer science. He was instrumental in the development of Common Lisp, of Java, and a bunch of other programming languages. In the 1998, at the ACM Uppsala conference, he gave a talk called Growing a Language, lessons from his experiences in developing and extending the computer languages that he'd worked with. The most important part of that talk that I got out of this was this quote: "If we grow the language in these few ways that allow extensibility, then we will not need to grow it in 100 other ways. The users can take on the rest of the task." Back in 1998, this was still a somewhat controversial statement. A lot of the languages that we started computer science with were difficult to extend. You had whatever was put into the language by the original designers, and that was about it. You were lucky at some point when we invented the ability to do arbitrary functions. But Guy was talking about something that today is a little bit more everywhere. It's ubiquitous. One of the examples he gave was numbers. Every language has ordinary numbers, addition, subtraction, multiplication on them. But there's a lot of different other types of numbers that different fields can use. You might want complex numbers with their own special rules. You might want rational numbers. You might want intervals, some number between A and B. You might want vectors or matrices. All of these are useful. All of these could be put into a language and could help out a significant help out a chunk of the programming community significantly. And we could say yes to adding any of these to the language. But if we said yes to all of them, if we added all of these to there, we suddenly have a huge complex type of number system in our language, something that's much harder to learn and harder to work with. You have a lot of weight that the average person, who pretty much just needs numbers, needs to care about, needs to be able to recognize, needs to be able to recognize the syntax of and understand at least a little bit of how they work with, even if they're never going to use it. CSS is in the same boat here. It's taken us a bit longer to learn it. We have 400 or so properties, each with their own unique microgrammars that you have to memorize, and no way to define your own. Houdini project in general is about changing this and finally allowing people to extend CSS, to take various pieces of the CSS engine and plug into it from JavaScript, adding your own functionality, changing it in ways that we didn't anticipate, giving you the velocity that we can't give you because, well, it takes a long time to do anything in CSS, or at least in a proper development cycle. I've been working on Flexbox my entire career, and so that's been 7 years. And it's stable now and usable, but I'm still tweaking it. Grid, 5 years old, and it's only just now becoming actually usable. And both of these are things that were desperately needed, but it still took forever. It took forever for us to recognize the need. It took us forever for us to write down the spec, and it took forever for it to be implemented and widely enough that everyone can depend on it. This is not great. Sometimes we guess wrong. We come up with things that people don't actually need very much of. And then we run into the same problem of you have a lot of things you have to care about, even if you're probably never going to use them. We can do better than that. And that's what Houdini is about. Now, let me check this. If you're following along at my slides, let me jump back real quick. At xanthia.com/talks, go to the 2017-06, today's date, and you can click on the links as you go along, because I'll link to all the specs. So we'll start off with custom properties. You've already seen some examples of that just a few minutes ago. So not too complicated here. Everything should be pretty fresh in your mind right now. You understand how this example works. But custom properties were originally sold as variables. I put it right in the spec name, CSS-variables, because variables were an easy sell. They were something that you could hold in your head and something you could understand the value of right away. But what they actually are is an extension point. Gregor pointed out a few places where he was using JavaScript to do some impressive things with variables, much more than just plugging in a value once and using it in several places. And we can take that a lot further now. The custom properties spec in Houdini, again present at this URL down here. You can just go to the plain domain and then find the list of all the specs. Lets us do a lot more. Custom properties as they are currently defined accept any value whatsoever. This is really useful. It means that we don't have to do anything. You just start using it and it works. But it means we don't know very much about it either from the browser side. So custom properties lets you specify a syntax for the property. That way we can show in DevTools when you put in the wrong type of value. It means we can transition and animate the property now that we know what the type is. It means that in general, there's a lot of transformations we can do. In a little bit, when I talk about typed OM, we'll be able to expose proper custom properties, ones registered with this API, in a much better way, rather than just, here's basically a string. Right now, the possible syntaxes you can use are very simple. This is intentional. We're trying to keep the spec easy to implement and easy to understand right now, and we'll see how it evolves as we go along and what things we need to allow to loosen this up. Variables also today always inherit. You can't make them stop inheriting. You specify it on one element, and it automatically applies to all the children, grandchildren, et cetera, below that. But if you look at CSS, most properties don't inherit. Anything that applies to text does, but if it applies to an element, like a padding or a border or anything like that, those don't inherit. You just specify them on one element, and children don't get that. If you want to do a custom property with that same sort of power, you're going to want to be able to turn off inheritance. And finally, if you notice in several of Gregor's examples, he was using default values on the for the root element, so that he could just define it once, and then on the root where they weren't being inherited, you would still get the initial value. With this new syntax, you'll be able to specify what that initial value is. That way you don't have to do any fancy tricks in your document to watch for that. You'll always have some useful value. So look at a quick example here. We're going to create a stop color property that's going to be used in a gradient in a moment. The specification is real simple. You call css.registerProperty, pass it an option bag, tell it what the property is that you're registering, what its syntax is, using the same syntax that you see in specifications. So this one's a color. Tell it what its initial value is, transparent keyword in this case, and this does not inherit. This is meant to just apply to some background on one element, not on any of its children. Then when we use it, it's used like a var, exactly like normal. Nothing changes on that part. But notice that now we can do a transition over stop color. Before we couldn't. Or rather, if you did, it was very limited in power. If you tried to transition from a red to a green using today's variables, it'll stay red through half the transition and suddenly flip to green and fill out the rest of the transition. It won't do a smooth transition like you want because it doesn't know what type it is. Now that it knows it's a color, though, it can say, all right, red, that's 255.00, green, that's 0.255.0. Let's transition nice and smoothly. So this allows a lot more power, makes them act like it's a real property, like everything else now. There's a bunch of stuff that we've punted to level 2 of this spec, however. Again, trying to keep things intentionally a little simple, hit the main use cases, and get something out quickly so that y'all can start using this, and then solve the more complicated problems in the future. One of the big ones is that there's no way to respond to a property right now. While you can change how it's interpreted, etc., you still have to treat it like a variable. You can pretty much just sub it into something, and that's all you can really do. Most properties aren't like that, though, in real CSS. You specify them, and then they have some non-obvious sort of behavior. This will be done in level 2 with something, probably as a computed value hook. I'm going to show an example of what it can look like. In this example, we're going to define a translateX property. If you're familiar with the transforms level 2 spec, we have translate, rotate, and scale subproperties now. They go alongside the transform property and just let you real easily specify a translate or a rotate, etc. So if we want to fake that up on our own, we have a translateX. It takes a length or a percentage or a calc combining the two. It starts out at 0, it's no translate at all, and it does not inherit, just like translate doesn't inherit. And then this is the example syntax. It'll look something like this in the future. So treat this as a possible future. We register a computed value hook. This is whenever we're figuring out the computed value of, in this case, the transform property listed under our outputs. We're going to figure that out by looking at the transform property's specified value and the specified value of any property with a --translate prefix. That's what the star means, everything like that. This will let us handle an X and a Y. You could do a Z as well, but in this example, I'm keeping it simple. Then you just define a function. It gets its input properties, it gets an output map, and you just do whatever you need to do. In this case, I go ahead and fetch the value of translate X and translate Y. If they're not defined on the element, that's fine. They'll get the 0 pixel initial value, so that works out just fine. I construct a new translate function using the typed OM, which I'll talk about in a moment. And then I set the transform value on the element to a new transform, starting with the translate I just built, and then ending with the rest of the transform that you might have specified otherwise. In use then, it's real simple. You just say your element has an X and a Y of 5 pixel or 10 pixel. This will transform my element by 5 pixels to the side and 10 pixels down. Or you can specify just 1 in the second example. Foobar, it'll go 20 pixels over and then that's it. 0 pixels down because it defaults to 0. You could combine this with a transform that does a rotate and a scale as well, and they'll just work together nice and seamlessly. Again, this is something that'll happen in level 2, however. So in that example, I used CSS transform value, I used CSS translate. These are new typed OM values. The existing CSS object model we've discussed a few times yesterday and today, or it's come up in examples at least. It's not very good. It did what it needed to do at the time, allow you to manipulate CSS values, but it's all with strings. Imagine if every JavaScript API was just taking in strings and you had to write out all of your class values as just a string that held something. I mean, we did talk a little bit about how everything's just string shuffling nowadays, but it's not a great model. It's a little clumsy, you have to do a lot more work than you should, and it's slow, actually. It's not that hard to construct a benchmark where the cost of the browser having to constantly parse your strings back into values for it to work on becomes the bottleneck. So the type 2M spec listed there is the solution here. Instead of just strings, it produces a bunch of ordinary JavaScript objects with convenient properties for it. The style map I'll get into in the next example, but things like numbers. If you want a 5 pixel value, instead of a string holding the characters 5px that you've got to manually throw a regular expression at, it'll be a CSS unit value object with a dot value of 5 and a dot unit of px. You can increment that, you can add it to other numbers. We'll get to a few examples in a moment. The basic stuff, the maps, are going to be exposed via properties like this. Elements will have a computed style map instead of a getComputedStyle L function. You'll ask it for the width property, looking exactly like JavaScript maps, and it'll return a value. You can similarly set it to whatever you want. And notice here, I'm setting up an aspect ratio by grabbing the width and then setting the height to whatever I got times 0.6. Using a little bit of the typed OM magic right there, all I had to do was call .mul and pass a number, and it automatically produces either a plain value or a calc for me, whatever I need, No parsing necessary. I don't have to manually figure out what the width was. This is actually a multi-map, which is used in a few places in some of the DOM APIs now. What this means is you can treat it like a map, and you'll get values out, you put values in. But actually, every key holds a list of values, which you can grab all of or set all of if you use specialized methods for it. A couple of properties, or rather a good chunk of properties in CSS are list valued. Background image, for example, takes a list of images. So if you just called style attribute map.get background image, you would just get the very first image in the list. But with get all, you'll get an array containing all of them. This sort of flexibility is required because CSS pretty regularly changes properties from being single values to being lists sometime in the future. This is something we've done a lot, and we're going to keep doing in the future. So we wanted to make sure that code didn't break if they were assuming it was a single value and it later became multiple. Having to use JavaScript syntax is sometimes better, sometimes worse for setting things. For example, rotate 45 degrees is just shorter to write than new CSS rotation, css.deg 45. A lot of times it's pretty similar. Simple values are not that much more complicated in the JavaScript form. And in others, it's much easier. I was already pointing out some math bits where it automatically figures out whether it needs to do a calc or not. It does all that automatically whether you're looking at a calc to start with or a plain value. The math stuff is going to make a lot of JavaScript manipulation of variables enormously easier. Several of the examples that I know Gregor was just using would have been easier if you could just do simple math on them instead of having to parse out and manipulate them that way. There's a few extensions to JavaScript that we're still hoping will happen that will make this even easier, though. We're not sure if they're going to happen at this point, but I'm still pushing the people, my other coworkers at Google, who work in TC39, the JavaScript standards body, to try and get these in. One that I'm really excited about, if it ever happens, is suffix constructors, letting you do simple numeric things with a suffix. You're familiar with these probably from C or C++, where you can do 5L to be a long. And if these showed up in JavaScript, then simple values would be way easier to write. Instead of css.em parenthesis 5, you would just say 5em. Looks like CSS now. That's great. If we ever get operator overloading, that'll make the math even simpler. You can just treat them like numbers, like the numbers that they are. Right now we have to use the Java-style math operations, which is a little bit clumsy, but still way better than the alternative. The typed web in general, like I said before too, gives real speed gains. There's a benchmark that, not a real benchmark, not like a competitive benchmark, but just something showing off the results of this all that have like 1,000 elements on the page who are being transformed around, just translated around the page, and updating them in a RAF loop, a request animation frame. And if you do that with the existing CSSOM, like 2/3 of your frame budget is blown just on string parsing. You're not even doing any string parsing yourself, just the browser having to parse the transform string and turn it back into an actual like internal, this is how far over I go, takes a significant amount of time. And it pretty much disappears completely if you do it in typed OM. Parsing equivalent stuff drops to essentially zero cost. It's really amazing. One thing I want to point out, because I just finished it and it took me a long time, so we're all going to talk about it, are the recent changes to the calc function, how to handle it in CSS object model. In the future, Houdini is going to introduce the ability to have custom units. For example, the print industry has a lot of interesting units, length units that it uses. One we recently added a little bit ago is the Q unit, which is for a 1/4 millimeter. Never knew that was something significant, but apparently it's used pretty heavily in Japanese typography. And so we added it to the spec. It's not hard to do. But if you have anything that you want to use in particular, unless you're a big publishing industry, you're probably not getting it added to the spec yourself. So we want to be able to let you extend those things. In the next level of values and units, we're also going to have unit algebra. That is dividing values with units or multiplying values with units together. This is especially useful to find out ratios of things. You want the ratio of a certain length to the width of the screen. You can say like 100 pixels divide by 100 VW, And that gives you a ratio you can then use in other stuff. Not possible today, will be possible in the future, and we needed to be able to make sure our design accommodated those. So what we settled on is you get the full syntax tree out of the type-to-wim when you have a calc. In this example, 1 times 2 plus 3 becomes a sum of a product, and that's about it. Product of 1, 2, and sum that with 3. More complicated expressions produce a correspondingly more complicated tree, but the benefit of this is that it will work in the future with everything, with any future stuff we do that we know of, without having to be changed or any weird awkwardness. So custom paint, we're getting to the actual extensions now. This was talked a little bit in Philip's talk yesterday too. In fact, I'm going to point out a very similar example to the one that he had working live. Custom paint lets you define new image sources, which is anywhere an image can be used in CSS. For example, Leovero's conic gradients request, which is now in the spec, wanted to have something like this syntax. In custom paint, the example would look something like this. There's a working example of it from Philip's talk, so look that over, but just real quickly go over. Say that you want a circle, pass it a new class, it takes in anything for arguments, do some parsing on your own, figure out where the center is going to be, what the radius is going to be, and then draw the color stops using the canvas methods. Again, working example from yesterday, you should look at that one more, but the end result is that you can just then use the paint function, pass it the name of the thing you need, conic gradient, and the arguments that it wants, and you'll get the conic gradient painted without having to wait for implementations to catch up. In the future, when we have custom functions, this will be even easier. Another few lines of code will let you write it directly, almost identical to what you would see when it's natively implemented, just with 2 more dashes in there. Those double dashes that you recognize from variables are going to be persistent in here. That's how we handle custom stuff to avoid colliding with browser-defined stuff. Quick diversion now to talk about worklets. This is what custom paint gets run in. They're a lighter version of a web worker, which was talked about a bit yesterday as well. We're going to need to be able to spin up a lot of these, and every web worker can be a separate process in some browsers like Chrome, and that's very expensive. New processes are hard. Worklets will run in a separate process, but will have just a few extra processes, spam the worklets out between them, kind of randomly, and we'll occasionally shut them down and restart them, maybe in the same process, maybe in another one. This gives us a pretty cheap way to have almost separate environments. You just can't depend on your worklet living for a long time and having global state, because every few seconds it'll probably get killed and restarted. Maybe in a different process, so its global state disappeared too. This encourages you to write nice functional code that doesn't depend on global state, without giving you a straight guarantee that would be a lot more expensive. Custom layout. Earlier, I talked about flex and grid and how long they took. And yet, the #1 request, now that grid is finished and out and usable, people want me to start working on masonry layout. Perfectly reasonable request. Masonry is great. I've been using masonry stuff for 10 years. I first started web dev learning jQuery and was using the jQuery masonry plugin. You can almost do masonry with grid, but not quite. It's a little clumsy and limited, and if you want a real experience with it, it's not going to work. And then, like Guy said in the beginning, we could add masonry, sure, but then people will just ask for another new layout method, and another one, and another one. All of them will be useful for the person who asked, and we would love to be able to give everyone what they need, but there's too many audiences here, too many people asking for different things, and not enough browser developers to do it. So we'd rather give you all the ability to do this in a useful amount of time. Now you can sort of do custom layout by yourself in JavaScript today. There's a bunch of libraries that do this. They're not very good for some simple reasons that have nothing to do with the skill of the author. It's just impossible or slow to do what needs to be done. In particular, layout, to do well, needs more information than you can get just from the style system. First of all, it needs to know what the sizes of its children are. Custom layouts today have a lot of ways to ask a child how large it's going to be in different circumstances. What's your minimum size? What's your maximum size? What's your preferred size if I have this much space to give you? None of these questions can be easily answered in JavaScript today. You can kind of fake it in some various hacky ways that are weird and pretty slow. We can do this way faster if we just give you access to that information directly. If you want some examples of this kind of child information usage, check out the Flexbox layout algorithm. It's got a bunch of stuff in its core layout steps. Similarly, your parent element might need to ask you for your sizes, and you can't hook into that. You just have whatever you've set your width to and your height to, which is going to be some static number. You can't say, oh, if I'm put into a float, I want to be this big, but I'll accept being only this big if I don't have enough space. But that's what everything else in CSS is allowed to do. You can ask everything what its preferred sizes are. And so we need some way to hook into that query process so that your elements can respond exactly as flexibly as built-in elements do. And finally, layout is one of the more heavily optimized parts of the browser today. Layout algorithms are complicated, and there's a lot of elements on an average page. And the number of elements just keeps growing, unfortunately. And so we have to do a lot of careful tuning to make sure that your page works reasonably, even when things are dynamically changing size and throwing out all the useful information. And so being able to, having to call over into JavaScript back and forth in the middle of all this can potentially make it even slower. Luckily, using Worklets, as we're doing with Paint, the Custom Paint API, makes this pretty reasonable. So the example I'm about to show you is very preliminary, it's very limited, and it doesn't do everything it needs to do, because layout's going to be one of the most complicated specs that you'll ever author to. I highly expect that very few people will end up writing a custom layout, but you should try it. It's fun. To do it well requires a lot of careful detail tracking. And the spec has a couple of really nice examples in it right now. They're fairly thorough and reasonably written. And when this is fully available, should be decent things to learn from as you go on. But let's take a look at it real quick. So to start, it looks a lot like custom paint. You start with the name of the layout method, and then you pass it a class. You can have it listed to other properties, just like custom paint. You can have input properties and output properties. But in this case, we're not going to do it. This example is a simplified form that works like display block, but centers all of its children. So let me run through this real quick. We'll ignore some of those arguments because they're either self-explanatory or not needed here. Big bit is we start at a block offset, that is how far down we've gone, of 0. We figure out how much size we have. We ask the parent to resolve all of our styles and tell us what our inline size is, how wide we're going to be. And then we start up a fresh list for all the fragments our children are going to produce. Then we loop through those children. For each one, tell the child to do some layout. Give it some amount of space. Usually it's going to be however wide I am. I'm going to pass that to the child and say, do your layout in this amount of space. It'll pass back the fragments that it generates. I can then position them by setting their block offset, how far down they go. And then if I want to center them, as I do here, I'm going to say whatever your size is, your width, we're going to just shift that over half of the way so that you get centered in your progression. Then we increment block offset, so the next element will start below. This next bit is complicated. I won't go over it too much. This is just if you're in a multi-call situation or something like that, where you might only get to lay out half of yourself and then the rest comes out at the top of another column. This is how you can store some information and get restarted later with the leftover stuff. Here, whatever much block offset you've used up, how big you are, and what children are left over are information that you might need to restart yourself with. So like I said, this example is skipping a whole lot, and I recommend reading the examples in the spec, because I took this from one and lightly altered it. They're a lot more informative and match the current thinking on the spec quite a bit more. So far, I've talked about specs that are in development right now. Custom Paint, as you saw, exists in Chrome, just behind a flag, and it's quickly going to be implemented in the other browsers. Custom Layout, we're in the process of implementing, and we'll probably get it behind a flag by the end of this year or early next year. Typed-OM is in the middle of being implemented right now. Same deal, behind a flag at the moment, but pretty soon we should be able to ship it unprefixed as soon as all the other browser vendors kind of catch up a little bit. Now we're going to move on to the things that don't exist yet. Things I haven't written the spec for yet, but I'm excited about. So first off is the custom parser. I already talked about typed-OM. It's how we're going to expose CSS values to you in a more convenient way. But a lot of the things that I'm going to be introducing here are going to be too complicated for plain CSS values. Right now, if you have something that's too complicated to express in the allowed syntax, like we had with the conate gradient, I had to write that its grammar was star, that allows anything. At the moment, those are exposed as just strings. We just give you the whole value as a string, you parse it yourself, you go crazy. We don't want that though. That's still way too much work when we could be doing most of that for you. We still know how to basically parse a string. Without any additional knowledge, we might not know exactly what everything means, but if we see a 5px, we know that's a unit value. Its value is 5, its unit is px. You go do what you want with it, but we can at least tell you that much. So the custom parser is our attempt to expose the typed-OM stuff for more arbitrary usages. One example of the plain parser APIs are the ability to parse arbitrary CSS constructs. This one, for example, if I want to just parse an arbitrary rule, I call css.parseRule, pass it a string I want it to parse for me. It'll return a promise because in case this is large, we want to be able to make sure it's nice and responsive. But when the promise resolves, the inside of it will contain a CSS qualified rule object. The prelude will be parsed as much as we can get, an ampersand, a space, a dot, and then a foo keyword. You can reassemble that into a selector as you will, because it might be something else. In the middle of a keyframes rule, for example, the selectors are percentages instead. So you'll have to handle that, but at least we can tell you, here's a keyword, here's a space, break it up a little bit. The body then will be a list of declarations. This has one declaration in this case, name of new prop, its value is a space, a keyword, and a space. Actually, I actually got that wrong. There's no space here. Pretend that last space isn't there. But this lets you do a lot of interesting work in things like CSS Next without them having to write their own CSS parsers, without everybody having their own representation of CSS underneath. This will be a standardized way to parse and represent CSS constructs, which will let libraries interoperate a lot better. There's a bunch more rules as well. You can parse an entire style sheet at once. You can parse an individual value. You can go anywhere between there. If you want a list of rules or a list of declarations, anything that you can do in CSS, you can turn into useful objects here. Custom functions, similar to variables, where those are like individual values you can pop in, a custom function lets you do an arbitrary extension at that value level. They're way more complicated than they look, and that's why I haven't written it yet. We'll get into the problems with it after an example. So in Philip's talk yesterday, he discussed the Darkin function that you could potentially do. So I'm going to implement that real quick. Start out with a name, --Darkin, its type. That is, when I use the Darkin function somewhere, what does it represent? We need to know that so we know if you say width : Darkin, we can throw that out at the parse time, but if you say color : Darkin, it's all right. So this is a color type. It'll return a color when it's done. And its input arguments are two, a color and a percentage, how much to darken it by. We then provide a callback that we'll use. It'll bring in the two input arguments, and then we just use, these are going to be typed-OM values because we know what type they are. So we just ask the color to give it to us in HSL form. We change the lightness of that color, and we return it. This will be the new color that Darkin represents. Here's a secondary example. The random function that Philip spent so long trying to polyfill, this should be all you need, actually. The new bit here is this per. I don't know what I actually want to call it, so I'm going to do that for now. That at the moment indicates that this function gets called once per element, not once per style sheet occurrence. Go back for a second. Whenever you use Darkin, you can just take it in the style sheet and then replace it with its value. It can then, whatever value you have, it's going to be the same for every element that gets that property. But as Philip's example showed, random is something we want to be different per element. So this will be some way of indicating the sort of context you're going to use the function in, when it needs to be evaluated. When you parse, when you apply it to an element, what? And the implementation is simple. It doesn't have any arguments, and it returns a random value. You just wrap it up in a CSS number so that it matches the type that we told it, that we said it was going to be, and you're done. Usage then is real simple. We can set up a variable first, store red in there, and then we want to darken it for something. So in foo, we just say --darken, give it a color, say 20% darker, done. Same deal with width and using random. Just multiply it by 100%, it returns a number. This exactly matches up with the types that calc accepts. So you'll get back a percentage between 0% and 100%. Now let's talk about why it's complicated. The code I gave you for Darkin a moment ago assumed that it was looking at an absolute color, something that could be an RGB or an HSL, which is the same sort of thing. But what happens if I pass current color keyword? Current color doesn't get turned into a real color until used value time, roughly the time that layout takes place. In this case, then, I can't resolve darken at parse time. This is going to have to resolve to a different value based on the element, and it's going to have to happen at a pretty late period in the value computation process. I'm not sure exactly how to indicate that and how to make it work automatically in the API yet. So that's something that I'll need to think pretty hard about in the future. Similarly, if you pass a percentage, in CSS, percentages are almost always relative to something. If you want to use a percentage in width, for example, it's relative to the width of the container. So when you use a percentage in a function, the question then becomes, what is that percentage relative to? Maybe you're okay with just working with it as a percentage, just doing the math on it, returning a calc or something. And that'll often work. But if you need it to be relative to a particular value, like you can do in a lot of CSS functions today, I'm not sure how to pass that information around yet. A lot of the existing CSS functions use more information than I was showing in the examples so far. The adder function, for example, looks at the element that it's being applied to and checks out its attribute values. How do I indicate that I'm going to need that and I need to re-evaluate the function whenever that attribute changes? The toggle function, not implemented anywhere, unfortunately, changes values based on what the inherited value is. It's used for if you nest two M elements inside of each other, the inner one is back to being normal text. And it's kind of internally implemented with a magical version of toggle inside the browser, so that it'll say either be italic or normal, the opposite of whatever my parent was. That's information from the style tree. In fact, it's information from the parent. var is the same deal. The var function takes the value of some property, some custom property. And how do I know? I need to be able to hook that up so that if you change that property, this function can evaluate to something differently. Similarly, I indicated in the examples, one back, there's only one output type. Random is defined to always return a number, but calc, the existing function, can return a bunch of things. It can be a number, it can be a length, it can be an angle. Any of the basic value types calc is able to represent. It only does one at a time, though, and we can always tell by looking at its arguments which one it's going to be. So the question then is, can we handle that? Or are you going to need to define a calc length function and a calc angle function if you want to do something similar for yourself? Not sure about that either yet. So there's a lot of interesting questions I'm going to have to answer before custom functions are, I think, ready for the future. There's probably a good level 1 I can define that does just the simple things that we've already looked at, but getting this to do it well going to be difficult. While custom functions existed at the value level, you use them in a property in place of some particular value. Custom at rules let you do something special at the level of rules, of style rules, of other at rules. These often don't rely on quite as much live information as CSS prop values do, so they're probably going to be easier to define in a powerful way. Let me show you a few examples, though, first. The actual code for this is going to be substantially more complicated, so I'm not going to show you that, just some examples of how it can be used in the future. One issue here that I always have is I really want to use SVG graphics, but you can't embed them in your style sheet. You always have to link to something external, even if it's a tiny file. A lot of simple SVG usages are a kilobyte or less, and I have to have a bunch of separate files for that, or do some spriting, or do something complicated, just to put these in. This is one reason why people do complicated things with gradients to draw instead, because you can embed that in your style sheet, no extra requests required. So one use of custom at rules could be to define SVG inside your style sheet. Just create a --SVG element, and then a couple more, such as --circle that are accepted inside of here. These just turn into an SVG tree, and then you could combine that with a custom function, --SVG, that just takes an ID, links it up together, and then turns itself into what we see at the bottom, a data URL of an SVG. That way there's no network requests that happen, just stuff inline in the file, and it's easy to work with. If you've ever tried to do this technique on your own and using a data URL, it's very frustrating because everything's just one big line and you can't easily edit it. It makes it much easier to edit. And you could potentially then expose useful stuff in JavaScript to make it even easier to edit on your own. Here's another example. People have always wanted the ability to nest selectors inside of CSS. If we're not offering that yet in CSS, but if you had custom at rules, you could do it on your own. We just create a --s nest rule. It ends up parsing some selector. Sorry about that semicolon. It's an artifact of my syntax highlighter. I can't get rid of it. It'll parse all that and then turn it into new styles for you. So the result of this, after your JavaScript runs, is that you'll have a new rule, .foo arrow .bar, that's just the result of substituting the ampersand, and applies it in normal CSS style. And with 2.5 minutes to go or so, that is the end of my talk. So we can move on to Q&A now.
Wow. Thank you very much. So if I understand this correctly, you don't want to write specs anymore, you want us to write the specs. Is that basically?
I mean, I don't want to put myself out of a job, but there's a lot of useful stuff I can still do, but there's way more that needs to be done than I am capable of doing. I don't want to write another layout spec for some time right now. Those have been, Flexbox and Grid have been a substantial chunk of my life, and that's a little painful. I want to do more useful things, more varied things for a bit.
Okay, yeah, makes sense. I have this question about the unknowns that you might know. Mm-hmm. Are there things we don't know we can do with CSS that you haven't seen us do? I'm always curious. I always have the feeling that we can do stuff that we don't know.
There always are. I'm not the cleverest person to ask about that. I do some web dev, but it's simple things, just applications for me and my wife to help around the house or whatever. The other people that were around early today, they're the ones that are actively involved in this and know all the really clever shit you can do.
Yeah. So you don't have any secrets?
No, nothing big.
No. Okay. So here's this question from somebody that says, are all browser vendors in on this?
Yes. One of the great things here is that, yes, we're all pretty excited about Houdini and are invested in it. Chrome is a little bit ahead of the game here just because we've got a lot of people we can throw at the problem, but everybody is closely following the specs, being very good at interacting with us and helping us write the specs. In particular, Microsoft's Greg Whitworth is pretty valuable in helping me write some of the custom layout spec and a few things related to parsing. And everybody is going to be implementing, or is in the process of implementing, the custom stuff that I told you about today. They just might be a little bit slower.
Okay, fantastic. So another question somebody asked, I wonder what Houdini will mean for maintaining or modifying other people's code. That might get a lot harder, especially for new devs.
While that's might be true, that's like saying that the ability to define new stuff in JavaScript makes life a lot harder for new devs. It can. You can define a lot of badly written things that just make everything complicated, or you can write some things that make everything a lot simpler and encapsulate some common patterns that the new dev can use a small, short thing, a new custom function, a new at rule, and instead of having to write lines and lines of CSS to do something, or do a bunch of weird stuff in a preprocessor, you just do one small library, a little bit of CSS, and their life becomes a lot easier.
So it could be that people who don't know CSS will try to write a grid layout spec on their own.
Yeah, and I encourage that. So like I said, layout's complicated, but a lot of it's complicated because I'm having to make sure that the spec handles all the languages of the world. Jen was just talking about writing modes. That is what makes layout complicated, making sure that it works correctly when I've got some Japanese text inside of an English page, but the parent is some Arabic. But all these mixed directions and sizing gets weird and it all has to work together just right. But you're not usually going to be writing one of those. Most of you are going to be writing a page in one language, or at least one type of language. Everything's going to be left to right, for example. And then it gets a lot easier. If I could do like an English-only grid, I could throw out like a third of the layout algorithm. And all that third would be the hardest parts of it, too. So even though layout's a bit complicated, it's not going to be as hard as it looks from the specs.
Okay. Thank you very much, Atkins.
Thank you.